with number 3, that's what I'm going over right now. This one presented you with gram and molarity, and then asked for volume. So you didn't have the normal stuff. So you had to finagle a way to solve for volume the same way you had been going, but instead of starting off with volume and molarity to get to moles, remember how you did M times V equals moles? You've been doing that again and again and again. Well, what if I just give you grams? That's easier than going to moles first, because I already give you grams straight up. But I give you milligrams here. So I showed my knowns here, the 55 and the 0.2, and I'm solving for volume. I have my BC written out, which you all probably already have down. I took my 55 milligrams of aluminum hydroxide. I went to grams by dividing by 1,000 milligrams, and then multiplied by the mole ratio of 1 AlOH3 and 3 HCl. The reason I did that, I'm sorry, I'm not there yet. I'm going too fast. 1 mole over 78 grams is what the molar mass of aluminum hydroxide is. The reason I did that is because I had milligrams gone already. I needed to get rid of grams first, and now I'm in moles of aluminum hydroxide. And now that I'm in moles of aluminum hydroxide, now you can do your normal mole ratio and then divide by volume. Divide by the inverse of molarity here. So my 3:1 here of HCl to aluminum allowed for me to get to moles of HCl. So moles of aluminum are gone, moles of aluminum are gone. 3 moles of HCl need to cancel out because I'm specifically looking for volume in milliliters. So if I get to liters first and then get to milliliters, I'm good. So my moles here, I can cancel by taking the molarity and inversing it. So remember, molarity means, I don't know, just turn it off. Molarity is moles per liter. So if you can help yourself by canceling units, then you can flip this upside down, and that's what I've done here. I put my number with the moles and put liters on top. Once I'm done, moles are gone, onto liters. I got 0.01057 liters, converted back to milliliters because that's specifically what it asked for. So the point of the matter is, I can give you dinosaurs and elephants, and if you can get to grams, then you can get to moles. And once you're to moles, you're going to do the same process. Multiply by mole ratio, and then at the end, just you might have to use molarity, you might have to use volume. Yeah.
So will a problem where you have to find volume start with milligrams, grams, something like that?
Or you can still do M times V, like I had been doing this previous problem, to get to moles. You can start with molarity and volume of the standard, the one you know everything about. This one you didn't have a specific standard. You didn't know for sure, but you did know you were solving for HCl, so that had to be right there. Alright, so there was one more thing, and on your desk you have this paper. It's got a titration setup, and this is what you guys are going to do on Monday. How many people are going to be gone for AP Psych Monday? Just a handful. Okay, so if I can, I'll switch the titration to Wednesday so you guys don't miss out on the titration, because you're going to have to make it up regardless. So if I do that, then I'll move forward. We're going to do acid-base mixture notes, and then we're going to have a whole day of just working in class on review. So, not almost a whole day. So, if anything, you guys on Tuesday after your AP Psych exam, but you might have to work on your review by yourself. So let's go over the first 2 parts of this one, and then I'll let you guys finish. Okay, so I've already started it here. This is yours. And so this is called at any point. At any point on the titration curve, you should be able to tell me the pH. And that's just basically stoichiometry over and over and over and over again. So on this one, I gave you HCl and sodium hydroxide. So I have the BC written out. Sodium hydroxide plus HCl gives water and NaCl. My titrant here is going to be the sodium hydroxide, because this is the one that I don't know the volume for. So this one's my titrant. The HCl, I know both the starting volume and the molarity, so that's got to be, I just lied to you. Okay, we're putting this in the titration burette, because sometimes we call the titrant the thing that we put in the burette. I'm flipping my words between my honors class and AP class, I'm sorry. This right here is going to go in our burette, and the reason why is because I'm slowly going to be adding volume through the titration, and you'll see that right here. The volume of base added, I incrementally go up. In my flask, in the very beginning of my experiment, just like on your titration simulation, in the flask you had HCl, and it told you the molarity here, 0.1, and you have 50 milliliters. So what I did in the very, very beginning, I wanted to see how many moles. In this case, I'm using millimoles. It's the same thing. It's just down the units different. I want to take how many millimoles I have in the flask. So I took my 50 times my 0.1 So you can see over here, 50 times 0.1 moles or millimoles per milliliter. So that right there, I'm zoomed in a whole lot. That right there, milliliters cancel, and I get 5.00 millimoles of HCl to start off with. And that's before the titration starts. That's right when you pop it into the flask. So HCl moles, I have it in millimoles, but it's 5.00. Before the titration starts when 0 milliliters of base has been added, you don't have any base in there, so I just put 0 as well. Has a reaction occurred at all here? No, so you haven't made any product either. Okay, so how do you find the pH of this? If HCl is the only thing in the solution, the HCl creates hydronium, right? It's going to be creating a pH of, what's the molarity of the HCl? 0.1. So negative log of HCl concentration, which was 0.10 molar. This right here in your calculator or in your head, either way works for me. This right here is negative log of 1 times 10 to the negative 1. Remember I told you that exponent controls your pH? Anything with the base 10, this is a pH of 1.0. You can try it in your calculator, but trust me, the exponent controls the pH. So you can actually do any log that has a 1 in the front and a base 10, you can do that in your head. So if I give you 1 times 10 to the negative 10, what's the pH? 10. Okay, 1 times 10 to the negative fifth is 5. That's only if you know that is the H plus concentration. That's nitrate. It has pH plus. So this pH is 1, and that makes sense. It's a strong acid. It's got a low pH. That's good. Now, what if we add 25 milliliters of base? I haven't changed my acid at all. It's still 5. So you can draw a line all the way through that column. It's going to be 5.0 millimoles the whole entire time. You're not adding any acid in this titration. You're only incrementally adding base. Then you add 25 milliliters. You want to take this and multiply by its molarity. What's the molarity of the base? 0.1 as well, right? So we got 0.1 in this one and 0.1 in that one. So I need to take this 25 milliliters times 0.100 millimoles per milliliter.
Attention, bus 277,
2.5
bus 1142
millimoles
today.
of base as well.
If you're interested in
So-
taking driver's ed this summer, come by and get a form in the front office and return to Ms. Falls by this Friday. Any student who has a signed bus form, bring it to the office of Ms. Falls before
Who is
you
your
leave
limiting
today.
Who is your limiting reagent? Who do I have
If you
less of
came
right
by
now?
during lunch today to pay a fee, please be sure and see Ms. Prenti before you leave today. Reminder students, tonight at 7 o'clock, the 5th annual talent show will be held. Admission is only $5. Come out and support your fellow Chargers performing. Also, don't forget to buy your prom tickets. The last day to purchase prom tickets is Monday. They are $50 and will be sold at all lunches on Monday. Attention all AP students, please be sure and visit the testing link on the Cox Mill webpage for important AP testing information. Cox Mill Young Republicans meeting is on Monday, May 5th from 2:30 to 4:30 in Ms. Kumar's room. Guest speakers include Assemblyman Larry Pittman, Assemblywoman Linda Johnson, and Cabarrus County Commissioner Jason Ostrich. Thank you. Have a great weekend.
Okay, let me tell you what I'm doing here. This is the method of limiting reagent that's a lot easier than what we used to do. If we have 5 millimoles of HCl and 2.5 millimoles of NaOH, this is less, so we are going to run out of this first. As this reacts in a 1-to-1 mole ratio, I'm going to use up every bit of this, right? And as this reacts in a 1-to-1 ratio, I'm only going to be able to use up the same amount of acid as I used of base. So how many millimoles of acid am I using? So I'm minusing 2.5 from that. How much is left over? 2.5, right? Millimoles. So the acid is in excess. That's controlling the pH. But that's not what I can put in pH. I can put millimoles per, what's my total volume used right now? That's just a base. How much acid do I have? 50, sorry. 50 milliliters of the acid plus the 25 milliliters of the base. Total solution is 75. So don't forget that whenever you have your millimoles, you need to divide by total volume, which is in this case is 75 milliliters. What's 25 divided by 75? 3 or 0.3333, right? So it's 1/3. But since we're over 1, when you go 0.033, let me make sure that's right. Yeah, 0.033 molar is what the HCl or H3O plus concentration is, which is the acid concentration. How do I find pH? Negative log. I can't do negative log of that in my head. Anybody got a calculator? Negative log of 0.033. 1.5. It makes sense. It's going up little bit by little bit, right? We added a little bit of basic, got a little bit more basic. So as you go, you're going to see that HCl is in excess and excess and excess until they meet the equivalence point. Well, what volume do you think the equivalence point is going to be? Knowing that we have 50 mils of that and 0.1 molar, and we have 0.1 molar of the base. I heard 50. Why? What's true at the equivalence point?
They're equal.
Moles equals moles, right? M times B. 50 times 0.1 was 5, right? We need this one to also be 5 at the equivalence point. So 0.1 times something gives me 5, 50. So maybe make a note on there. At 50 is going to be the equivalence point. What should be the pH? 7. But why is it 7? Because we have a what acid? Yeah, strong acid, strong base. 1 second. So strong acid, strong base yields a pH of 7. Strong base, strong acid. Strong base, weak acid would yield a pH of greater than 7. Okay, so you can see that the equivalence point, the actual volume might be exactly the same, but the pH can be up or down. Try your best to finish this worksheet over the weekend. On your way out, you need to turn in problem set 19A and your titration problems. I'll answer questions now.
Those two old phones, will they always be the same?
What do you mean always the same?
Like,